Hello, in this video I'm talking about AI's secret weapon. It's called the Interphase IP Boom. IP stands for intellectual property. It's the secret weapon is ultimately the interface intellectual property boom. Here's some background. In this video, we discuss an extraordinary trend. I think it's really interesting. It's a really interesting trend. It's also transforming the semiconductor field, and that is the rapid expansion of interface IP. This video, it's based off of a recent article from SemiWiki, but it's completely different. The video is changed and has a different, like a completely different perspective and different angle. It touches it from a different viewpoint. Basically, it's a more technical viewpoint, more technology involved, but I do incorporate some like market, stuff involved here in business related concepts like revenue and stuff later on in the video. And I do talk about, I do make it mostly technical about technology, but I do include like the market things. And here's one of those things. There's the article from SemiWiki. It showed a like rapid increase in the use of interface IP technology. It was a 23.5% yearly increase. That's quite significant, and we're going to talk about what is making this happen and what implications there are about this for electrical engineering and we're going to focus on the market in general as well. As you can see here on the bottom left and bottom right, I have like different graphs and charts and stuff showing or focusing on AI and different statistics on AI and growth. Like this one on the left, it's showing growth that's projected through the years. The one on the right is I think that's a pie chart. It's showing some other data and statistics, stuff like that. So first of all, understanding interface IP, what it is. Interface IP refers to pre-engineered, pre-engineered, designed before, and thoroughly validated, well checked and confirmed parts of intellectual property that are responsible for being in charge of communication. So ultimately, the interface IP technology, they're parts and components that are in charge of communication. Consider it like this: they're basically highways and entrances, and they're needed for accessing and exiting a semiconductor chip. That's basically what they are, kind of, pretty much. And they're very important because they're used in a lot of technology and some specific examples of that, like of technology they're used in coherent buses for CPUs and accelerators, as well as external interfaces, including high-speed serial links for PCIe, USB. They're also used in memory connections, different types like memory DDR. And they're highly essential because without them, the complex processing units would not be able to communicate effectively with each other or the environment around them. So now here we're going to talk about why this boom is happening. The cause of this rapid expansion is mainly due to artificial intelligence. And that's because AI accelerators and processors are becoming more complex. They're combining numerous specialized computational engines, memory controllers. The technology is becoming more complicated for AI, and AI demands more complex technology. That's an increasing trend, and sometimes like I/O units are they're placed on one chip, sometimes across several chiplets. See, it becomes more complex. And ultimately, these large scale parallel systems require advanced standards. There has to be advanced data bandwidth and minimal latency in communication. Um, and the interface IP, intellectual property, specifically high bandwidth standards, and those would be things like PCIe and Gen 6/7 or CXL and UCIe, different high bandwidth standards type of technology, like mentioned here. They're foundational technology here. They're quite important here. And 23.5% year over year increase represents the market requirement for chips capable of meeting the large amounts of data for AI. So increase. And ultimately, this leads to significant investments in these essential communication components. So that's, as you can see, there's more investment into these components, the communication components, which are the interface IP. Those are the communication components. So there's more people investing into them, and that's what's leading to the 23% yearly increase in the use of this technology. Okay. And here I have some images on the bottom left and bottom right. So as you can see on the bottom left, I have like an image of a chip, and there are different components and parts. Here it says SoC, that stands for systems on a chip. And there's different parts to it, like the CPU, and there's the digital core, and all sorts of different processors, like the SMS processor, and different like data being transmitted and stuff, that kind of thing. And here on the bottom right, there's an image showing the interface IP. This is from another like company, Altera. And this is an image showing the IP ecosystem. They talk about the IP cores, like the main part about the IP and silicon that's important in chips and semiconductor development. Talk about that and connect it to IP. Talk about like IP partners and other companies that are also designing um, similar technology, communication technology. That's also interface IP technology and different reference designs they have and development the kits and stuff. They also have some design software, like how the software is developed in these interface IP technologies and stuff. And here I'm going to talk about the challenges and innovations in interface IP. I'm going to specifically focus on the challenges involved in this. So creating this type of interface IP has significant challenges in electrical engineering. And some of the specific challenges would be, well, first of all, there's high data rates. And the data is in terabits per second. That's quite big. That's significant. And at the same time, while there's this high data in terabits per second, you have to also meet these certain standards. Like you have to address challenges, and those challenges would be things like signal integrity across large traces, which is a complicated thing to do because the large traces are complex, and the signals have to be there has to be a significant signal integrity. There has to be you have to be reducing power consumption for swift connections, but that's there's a catch to that also. Swift connections, that makes it harder to reduce power consumption. That's a challenge as well. And you have to also at the same time maintain electromagnetic compatibility, both electric compatibility and magnetic compatibility. That has its challenges as well, which is also not an easy thing to do because it's complicated as well. And all of this under the considering the high data rates, terabits per second, so that makes it quite complicated to make these interface IP. Those are some of the challenges involved in that. And then it also encompasses intricate, complex mixed signal design and analog circuit adjustments that are accurate. That's also important. There's also advanced digital logic involved. You use that to execute complicated protocols. There's advancements in architectures, these type of SerDes architectures. There's and here are some of the like advancements in technology. There are advancements in SerDes architectures, adaptive equalization, and there are even new materials being developed for interconnects, and these are all important factors to consider. It is important to consistently advance the limits of what is possible with silicon in order to meet the needs of AI. That's like the ultimate solution here to solve that problem. Here we're going to talk about the impact that these interface IP have on the industry. So this expansion reveals much about the strategic trajectory of the semiconductor industry. So it's a significant representation of how the semiconductor industry is doing in general. And firms focused on interface IP, those would be things like companies like Synopsys, Cadence, and other types of specialized IP providers. They're experiencing major revenue growth. This affects their stock prices. And also, chip designers are they're starting to use interface IPs more often. They're using them to make complex AI for systems on the chip, and this trend is showing to be increasing slowly, and it's been significantly increasing, and as a result, there are also more people spending on the interface IP, and they're doing this to seize future market presence in AI hardware. Basically, take part more in the market presence of artificial intelligence, specifically the hardware of artificial intelligence. Now I'm gonna make like a future outlook here. So my prediction is that the constant demand from AI will advance interface technology even more. Basically that the interface IP will increase even more at even a faster rate, I think, than it is now. And here I explained in this few sentence paragraph, I explained the reason for this. Basically, the ongoing advancement of AI, especially in fields such as large language models and instant processing, it's generates significant need for data. So basically, AI becomes more complex. There's more complexity, and as a result, to solve these issues, there have to be these interface IP to be able to solve this issue, and it's a pretty good solution to this. It makes the IP development makes the result quicker, more efficient, and more scalable in the communication solutions. I think the more scalable and accurate, So that's the ultimate conclusion. Make sure to leave your comments on what you think, and see you in the next